The last conic section is the hyperbola. And a hyperbola is a set of all points whose distances to two fixed points subtract to give the same constant. It's okay if you don't know what that is. But the standard form of a hyperbola is going to look a lot like an ellipse, except you have a subtraction sign in between. And sometimes the y is first. So depending on if the x fraction is first or the y fraction is first, your hyperbolas can open different places. Right? So if the hyperbola has the x fraction first, like this one, then it is going to open left and right. If the hyperbola has the y fraction first, like that one, then it's going to open up and down. So the center is found the exact same way as an ellipse. The numbers that you move left and right are found the exact same way as an ellipse. You look under the x, take the square root, that's left and right. Under the y, take the square root, that's up and down. But we don't draw an oval shape with those values. You actually draw a box, and it creates this x shape of asymptotes that the hyperbola is going to follow. Okay, so let's look at some examples. So we will go ahead and identify the center, the directions of opening, how many we're going to move left and right and up and down, and then we're going to match the graph, right? And so on number 1, our center, we'd look inside the x parentheses, change the sign. Look inside the y parentheses, change the sign. Right? So because this one, the x fraction is first, this is one of the hyperbolas that's going to open left and right, like the x-axis. All right, to figure out if we were going to draw that box, we would look under the x and take the square root of that number. That's going to be 2 left and right. Up and down, we look under the y, and we take the square root of that number. That's going to be the square root of 5 up and down. And so it's okay if you don't know the square root of 5. I'm just going to type in the calculator. That's approximately 2.236. Okay. Now we have two graphs. No, sorry, we just have one graph that's opening left and right. And so it should be the right one, but we'll just double check. Now, on the calculator and on the ACT, you're not going to see this box that was here. So definitely it should be this A one, where we go to the center of 2, -1, and then we would move 2 left and right. That would be here and here, and then 2.2 up and down. So about there and there. And then that would be the box. And then you would have this X's that would go like that. I kind of missed my box. And so this definitely does match up. That's going to be graph A. So sometimes you can figure it out without actually drawing the box. Sometimes it might help you if there are two graphs that look very, very similar. All right, let's look at number 2. The center, we go make sure you go to the x fraction first to get the x coordinate, and then do the y, changing the sign on each of those. Okay, and then to figure out the direction of opening, the y fraction is first. This is going to be an up and down hyperbola. Okay, to figure out how many to move left and right, make sure you look at the x fraction and take the square root. And then up and down, look at the y fraction, take the square root. So we have 2 of these, and B and C open up and down, but it looks like C is the one that matches the center, sorry. So the center is -2, 3, and so that's going to be this one. This one's center, I think, is 3, -2, or something weird. So that's choice B. Okay, so your assignment is to do what we just did with 4 on your own.